All right, this is the last new lesson for Chapter 6 for my grade 11 applied students. And all we're doing now is we're adding kind of one new thing to our system of linear inequalities. We're adding optimization. How do we find an optimal answer? So we got a couple of little definitions to do here first. First definition is, what is an optimization problem? And that is oh, hang on, pen's not working. Hang on. Sorry. There we go. A problem where a quantity, that means an amount that you're counting or measuring, quantity must be maximized, which means made as big as possible, or minimized, which means make as small as possible, using a system of inequalities. So that's what an optimization problem is. It's a problem where a quantity must be maximized or minimized using a system of inequalities. The objective function is the equation that represents the relationship between the variables in a system being optimized. I'll give you a sec to catch up to me. While you're catching up to my writing, think about the word equation. Are the things we just graphed in our warm-up today, our ACC, are any of those equations? No, they're inequalities because they don't have just an equals in them. So that's what's different about the objective function from the other things we've been finding. The other things we've been finding this unit all have either a greater than, a less than, a greater than or equal to, a less than or equal to. What we're going to add to these problems we've been doing is just one straight up equals. Everybody caught up to me? Our first example, I won't move it all the way up if you're still writing those words. Our first example is, a company makes couches and love seats. Due to constraints in the work area, no more than 10 couches can be made, and no more than 15 love seats can be made. That's supposed to be love seats, not love Sears. No matter how much you love Sears, Sears is gone. There we go. Can be made in one day. In total, no more than 20 pieces of furniture can be made in one day. Again, no more than. All those things I just underlined. No more than, no more than, no more than. Those are all inequalities. Let X represent the number of couches, Y represent the number of love seats made in one day. The company profits $300 on couches and $400 on love seats. The company wants to maximize its profits. What combination of couches and love seats should be produced? Okay, the first part of this question is just like the examples we did the other day. First, I have to define what my variables are. So let X equal number of couches made in one day, and Y will equal the number of love seats, which is like a mini couch, made in one day. I think in the actual furniture industry, you call it a couch if it seats 4 or more, and you call it a love seat if it's 3 or less. And if it only seats 1, it's a chair, I believe. I think that's the way it works. Anyway, I might be wrong about that. Anybody in the furniture business? Anyway, write a system of inequalities to represent this situation. All right, what are my constraints here? Well, for starters, let's go back to my words. No more than 10 couches can be made in a day. So X has to be less than or equal to 10, right? It could be 10, but no more than 10. Love seats, what was the constraint on that? 15, so less than or equal to 15. What's my constraint for the entire production day? 20. So X plus Y is less than or equal to 20. I again have probably a couple that are almost just obvious. Obviously, you're not going to make negative couches and negative love seats in a day, so those are kind of understood to be true. And what kind of numbers are all these systems part of? They all got to be whole numbers this time. So X and Y are elements of whole numbers. All of that stuff's true. That's all the stuff we've been doing so far. What am I adding to this? I'm adding the part for part C. I should probably put this in a curvy bracket because it's sets. And I should probably learn how to draw those brackets better. My word, that's ugly. But anyway, objective function is this. I'll get to your question in a sec. The objective function is that I profit. Now go back to what it says in that last sentence there. $300 for every couch and $400 for every love seat. So my profit will equal 300x plus 400y. And notice that one is an equation. Because it's not more than, it's not at least, it's not up to. That's what my profit is. And I'm actually not even going to graph that equation. Notice I can't. It has an extra variable in it. My job is I want to make this value called profit as high as possible. That's why I'm looking for the optimal solution in my solution set. And that's why we call this an optimization problem. Okay, what was your question? Did it actually say that in the question? Oh yeah, it did. They actually did A for you in this question. That won't happen on a test. That will be your job. It's supposed to be wrong, but you know what? This is not a highly technical, pure math theory course. I don't think I'd take off. The question was, would you lose any marks if you forgot these brackets? No. Maybe I should give you a bonus mark if you can make prettier brackets than that, though. Boy, that was actually, my right one's not too bad. That one's not bad. This one's, bleh. I gotta practice these. Oh. The slower I do it, the uglier they get. There we go. Oh, that one's not bad. Because I need practice drawing brackets. Bad at it. Okay. All right, we're going to graph our system of inequalities. Here we go. We'll do this quickly because we want to get through like 3 examples today. All right, so here we go. First example, or first inequality is x is less than or equal to 10. So draw me a straight line through x is 10. And I think I'll do the opposite shading again. So it's less than or equal to, so I'm going to shade everything to the right. I am, yes, like I just said, I'm doing reverse shading. Because again, we've got like a bunch of answers. And I'm not going to bother with the whole x is greater than 0, y is greater than 0, because I'm just going to, notice my graph doesn't even have numbers that are negative. But I know that that's true, right? This is where the graph ends, on the left and on the bottom. Okay, so there's the first inequality. The second inequality is y has to be less than or equal to 15. So at 15, go this way. And again, less than or equal to means we go down, right? So opposite shading, shade above. Oh, and again, my shading skills. Oh, and over the line. Good enough. You get the idea. All right, so those are the easy ones. Now, x plus y is less than or equal to 20. I'll write that one down just to remind ourselves. X plus y is less than or equal to 20. Okay, do a little bit of arithmetic, or sorry, algebra to rearrange that maybe. And 20 is my y-intercept, but my slope is negative 1 over 1. So down 1 over 1, down 1 over 1, down 1 over 1. Actually, why don't I just know that it goes to 20 that way? And then corner, 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 corner. Oh, got a little bit crooked at the end, but that's okay. That's not in our solution set anyway. Question? Because that's what this number is. What number is in front of my x? Negative 1. Write that as a fraction. Negative 1 over 1. Would you prefer thinking of it as 1 over negative 1? Because that's the same number. Right? What number is in front of x when you just say x? 1. What number is in front of x when you say negative x? Negative 1. Right? There's always a coefficient on x. We just don't bother writing it down when it's 1. All right, now which way are we shading? Let's do a test. Test 0, 0. 0 plus 0 is less than or equal to 20. Yes, it is. So in an opposite shading world, don't include 0, 0 in the answer, which means that I'm shading this way, which kind of cuts off the rest of this. So that's it. That's my answer zone. Everything in the white part. Now, how do we figure out of all of these points? Now remember, we can't count the spaces, right? You can't make 1.7 love seats. Well, maybe you could. We break for lunch when we're in the middle of a love seat. But you get the idea. We're not finished, right? We have to make entire couches and entire love seats. So that's why it's whole numbers. So if I really wanted to be fancy, I could go through here and put dots on all of the corners, but I'm not going to bother. Especially since these aren't all the answers I want. I want whatever answers will make P be as big as possible. Guess what the answers have to be? They have to be the corner points of whatever shape you just made. We just made a quadrilateral. It has a corner here and a line, corner here and a line. That's me trying to draw the line. Corner here and a line. Those corners have to be, one of those points makes it the maximum possible. So my corner points are 0, 15. That's this one up here, right? This one here I can read as 5, 15. The next corner here is 10, 10. And finally, the last corner is at the bottom, 10, 0. So there, my graph has done its job. I don't need it anymore. Meh. What do I do with these points? Because what are we trying to do again? We're trying to make this equation, what was it again? 300x plus 400y. We want to make that equation as big as possible. 0, 0 is obviously not the right answer. And I'm glad you brought that up. He said, why didn't we care about the corner at 0, 0? Well, clearly, that's not going to make it as big as possible. And while I'm on the subject, wouldn't 5, 15 for sure have to make a bigger answer than 0, 15? So don't bother trying that one either. And then while we're on the subject again, wouldn't 10, 10 have to make a bigger profit than 10, 0? But which of those two is it? You know what? I kind of have to try. So let's try 5, 15. What is the profit when x is 5 and y is 15? And I already did the calculation on that. This is the part that we'd for sure let you have a calculator for. And that would be $7,500 of profit if they make 5 couches and 15 love seats. What do you think? The other point I have to try is 10, 10. If I made 10 couches and 10 love seats, I get 300 times 10 plus 400 times 10, and that one is only going to give me 7,000. So the winner is that one. Therefore, maximum, are you okay with maximum being just abbreviated as max? Maximum profit happens when we make 5 couches, right, because X was 5, and 15 love seats, because Y was 15, per day. And this kind of math is absolutely essential to the business world. If you've ever wondered what the difference between an actuary and an accountant is, besides the fact that actuaries tend to get paid more, it's that accountants tend to deal with after your sales, like keeping track of your profit and loss once you've gone out and done your business. But an actuary is somebody who tells you how to set up your business. What do you set your prices as to get the best possible profit? I remember when the Winnipeg Jets moved back here from Atlanta, right? We had the Winnipeg Jets in the 70s. They became part of the NHL in the very late 70s, 79. And then we had them until about 1994 when the Canadian dollar fell so low that all the Canadians, even Toronto and Montreal were struggling, but a little city like Winnipeg, we lost our NHL team to the States where all the money is. And they've never made a profit where they moved to ever since. But anyway, we got our team back for a number of reasons, one of which is one of the richest guys on the planet decided they'd like to see a team here. And when one of the richest guys on the planet wants something, they usually get it, right? So, right, thank you, David Thompson. And of course, Mark Chipman is also one of Canada's wealthiest men. So those two guys getting together, that's why it happened. But also, the economy in Canada recovered quite a bit compared to the States. But when they built, but the old arena we used to have was not going to be good enough for an NHL team. So they built a new one, and that's what's not called the MTS Center, Bell Center now? Whatever it's called. Whatever it's called, that big fancy arena downtown was built because the Jets were going to come back. But it's the smallest rink in the league. Now some people would say, well, you have the smallest city in the NHL. But a lot of people, when it was built, were like, well, why not build a bigger arena? It sells out every game pretty much. Why not build a bigger arena? And I remember an interview with Mark Chipman, the co-owner. He said, we did a lot of studies, and we found that this is the right size arena for our market. And what he means by that is that, if you think about a hockey arena, there's my hockey rink. Well, no matter how big you want to make the arena, there's only so many seats close to the ice. And then, of course, you have to start moving up. Right? You make a second tier and a third tier. Well, by the time you get to the third tier, nobody wants to pay a ton of money for the cheap seats that are a long way away. But in a city like Toronto or Montreal, where you have literally millions of people who want to go to a hockey game, you can make those upper deck areas enormous. And that's why you get 20,000 seat arenas when ours is only 14. Well, why didn't we build one of those arenas? Because the market research they did told them that if they put too many of the high seats up here, there isn't enough people in Winnipeg for the low seats to fill up. And the profit here is higher than the profit there. So that's the kind of math they do. It's like, you make more profit by building a smaller arena? Yes, because I'm not selling as many cheap seats, because more people will fill up the expensive seats. That's the kind of math that business people have to do. And again, that tends to be actuarial math. Now, all of these situations are linear. For now, next chapter we're going to look at some quadratic, which means that you have x squareds instead of just x's and y's. But all of these are based on the concept that straight lines have to meet somewhere. And if you have multiple straight lines meeting, you're going to have some sort of shape. And the corners of these shapes will, at least one of those corners, will be your optimal placement. So there we go. So that's what the stuff we're doing. So let's do another one. A local craft store produces bracelets and necklaces. The craft store uses 2 different machines to make their jewelry, a cutting machine and a polishing machine. There is a maximum, I'm underlining that word because I know it's going to be important, of 225 minutes of cutting time and a maximum of 200 minutes of polishing time. Each bracelet requires 15 minutes of cutting, and each necklace requires 15 minutes of cutting. Each bracelet requires 10 minutes of polishing. Each necklace requires 20 minutes of polishing. The shop makes a profit of $5 on each bracelet and $7 on each necklace. They're telling us again X is bracelets and Y is necklaces so that we all get the same picture. And let's make our equations. All right, let's make a cutting equation. If X is how many bracelets I'm producing, 15X is how long it takes to cut them all. If it takes 15 minutes to cut the necklaces, 15Y is how much time it takes to cut them all. And I have a maximum cutting time of 225. So 225, if there's a maximum, what kind of a symbol do you want? Equals and less than. Very good, because you can't go over it. It's a maximum. Okay, let's make a polishing equation. It takes 10 minutes to polish the X's, and it takes 20 minutes to polish the Y's. So obviously the necklaces are maybe a little more finicky for the guys. They got to polish a little longer. But I have a maximum amount of time I can polish, 200 minutes. So once again, less than or equal to 200. Now once again, obviously you can't make negative bracelets. You can't make negative necklaces. And once again, I'm going to have to count in whole numbers when I'm looking for my answers. But I have one more equation I need. I need my optimization equation. My objective equation is what they called it in your notes. What is the profit based on? Profit is based on, I make $5 for each bracelet and $7 for each necklace. So, what's this one going to look like? Okay, for this one, let's use Desmos. Okay, so for Desmos, we're going to open up Desmos. And here, let me move over Desmos. There you are, Desmos. Desmos. Okay, so the first one was, what was it again? 15x plus 15y. And okay, I'm going to use my opposite rule again. So it was a less than or equal, so I'm going to put in a greater than or equal to 225. And, okay, there it is. I've graphed it. Doesn't it look great? Okay, obviously I'm going to have to move over a bit. Maybe shrink down and move over. There we go. Remember, we don't care about anything negative. As far as we're concerned, this negative part of the graph on the left and on the bottom doesn't exist, because you can't make negative bracelets and necklaces. Okay, how about the next one? The next one was 10x plus 20y is less than or equal to, oops, I just typed a 0 instead of the letter O instead of a 0. 20y, and it's less than or equal to, so again, using the opposite rule, it's not a rule, just using the opposite so that I can see what I'm graphing without looking at all these colors, is 200. And there it is. The white zone inside the X and Y axis is my answer. So I'm going to graph that answer on the grid provided. So that point there is 0, 10. So I'm going to go to my grid and put down 0, 10. I'm going to go back to Desmos. And this point here is 10, 5. So I'm going to go back to Desmos and go 10 over 1, 2, 3, 4, 5. So this is my zone here from there to, oh, that's a terrible, I'm going to undo that. Let's try that again. Let's make a nice straight line. Oh, I don't want to play with that thing. It takes too long. There we go. That's a better straight line. And then from there, it kind of changes directions again. and it goes to, what's the x-intercept that we want? Back to Desmos. Oops, you're not Desmos. Imposter. There you are. That's 15, 0. So go to 15, 0. And that's exactly true, isn't it? Oh, I drew that really ugly again. I'm very frustrated with my lack of drawing skills. So there we go. So everything else out there would be the shaded part, everything out here. And of course, this line would keep going this way, and this line would keep going that way. But really, all of this is shaded because all of this isn't the solution set. And everything white is my solution set. By the way, this wouldn't have been a very hard one for you to graph by hand, but I thought, we'll just use the technology for this one. So now, I didn't put this last point on. Let me label that. What was this again? This was 15, 0. So I know that my maximum profit will happen at one of those 4 dots. 0, 0 is a waste of time to even think about. Obviously, you get no profit if you put zeros in for X and Y. And I don't know, does 0, 10 or 15, 0 have to be ruled out this time? I think I better try them. So I'm going to try, first of all, 0, 10. So run 0, 10 through this equation, and my profit is 5 times 0 plus 7 times 10, which is $70. Now I'm going to try 10, 5. And if I try 10, 5, X is 10, Y is 5, 10 plus 35, or sorry, 50 plus 35 is $85. So already that's a winner. And then there is one more point. We'll try it just to be complete here. 15, 0. And if I put 15, 0 through here, I get 15 times 5, which is n plus 0 times 7. And that's 75. So my winner, clearly, is that one. And I don't have a whole lot of room here. You could write it on top of this graph. Therefore, making 10 bracelets and 5 necklaces gives a maximum profit per day of $85. So that's my solution. Okay, I'll give you a second to catch up to me. People who are all caught up, feel free to start reading the last example. We'll get through one more here. A toy company is making toy cars. One's a race car and one's a toy SUV, because that's what kids want to play with, is the toy SUV. It's like, whoa, pulling the kids into soccer practice. You know, like, no kid. The kids are going to want the sports car, but we'll humor the question and pretend like there's a market for toy SUVs. Yeah. All right, so ready to move on? Some people, okay, I'll give you a sec. There's still some people jotting down the details of this one. Again, people who are ready to move on, start thinking about the next one. Start making your equations. This time, they don't tell us which one should be X and which one should be Y. So let's make sure we all do it the same way so that we all have the same answer that we're looking at. Let's all decide that X will be the race cars. Okay, can I move on now? All right, so first step is to define our variables. First step is to make the pen work. Go away. Let X equal number of race cars. No, it's produced. This is about materials and production. Made per day. And we'll let Y equal the number of SUVs made per day. So there's x and y. So now let's start making our equations, or sorry, our inequalities. What are the things that limit us? No more than 40 race cars. So x is greater than, or sorry, less than or equal to 40. And again, the sport utility vehicles, there's only so many materials to go around, less than or equal to 60. By the way, limits on materials is going to be an enormous part of your life growing up. Where they're already saying, like, the reason why, well, I don't know if it's 100% the reason why, but as you can see, I'm rocking an old-fashioned iPod Classic. I don't want my music on my phone. I like my music to be on a separate object from my phone. But they're not making these anymore. Now they're saying that the problem is that there's a shortage of neodymium. Those of you in chemistry, neodymium, they use that metal when they make these, and they're saying that that's the reason. I honestly think the reason mainly is because I can't buy apps for this, right? I'm not a customer for their freemium games and for their apps that you buy in the App Store. I can just put music on this and that's all. The only money they get from me afterwards is iTunes money, right? And what's that?
Nobody really buys them anymore.
And plus, yeah, I'm one of the few people actually that actually pays for music nowadays. But you get the idea. They've phased this out, at least in part. They're probably not 100% lying to me. Part of the reason they probably don't make these anymore, because these are superior to iPhones when it comes to music in every way. This is the best thing they've ever made for putting music on a small device. And part of the reason is probably they're just out of, or neodymium's gotten so rare and so expensive is that they can't make them like this anymore. That's going to be an enormous thing. We already are experiencing a shortage of cars right now because of the chips that they use to run modern engines. There's a shortage of them. There's going to be a very big difference in the future of buying technology because they're going to switch now to, instead of things that you buy that you know you're only going to get a few years out of, it's going to switch to things lasting much longer because materials are going to get scarce. Your grandparents bought a fridge and it probably still runs 50 years later. That's going to happen again. So the market will be repairs. Repair people will be like gold. You think doctors are going to make the money? No, it'll be air conditioning repairmen. They probably already make about as much as a doctor if they own the business, that's for sure. But that's what it's going to be. The skilled trades already are in demand. The demand is going to go absolutely through the roof because people aren't going to buy a dishwasher and then, well, 6 years later it broke down, we'll get a new one. Nope. The materials just won't be there. You're going to have to deal with that. Dishwasher is your 20, 25-year dishwasher. When it breaks down, you got to get it fixed. And I think phones will go the same way. How many people get a new phone every year because the new iPhone comes out? No. It'll start expanding. People will have their phones for 5 years, then 10 years. Then next thing you know, you'll have a 20-year phone. It'll be upgradable. It'll be updatable. It'll be fixable. And the guys who can fix them are going to be the guys who are employed. Not to mention the guys who can write the codes for the new programs for them. Coders will always be in demand. Anyway, what is the other equation? I seem to be missing an equation. Oh, the 70. I haven't used the 70 yet. There it is. X plus Y. Oh, yeah. Very good. You notice that this one's not a less than. This is like a company that says you must make. This is what you call a quota, right? Anybody have a business or go to have a job where there's a quota? You must sell this much each day. You must make at least 70 things every day. That's your quota. So that's a greater than or equal to. Okay, so let's start graphing. Let's count by ones, shall we? I'm going to make this a little smaller so that it fits. Because these things are ones, right? Oops. Go away. Right? So this is 10, 20. Oh, I guess these are twos then. Yeah, we're counting by twos, my bad. So this is going to be, let me put this on here, 10, 20, 30, 40, 10, 20, 30, 40. If we don't count by that, we're never going to make this work. Okay, we'll do this one by hand. These are easy equations. X is less than 40. So that's this line right here. Oh, let me try that again. Okay, so X is less than 40, less than or equal to. Pretend I can draw a straight line. And okay, less than is shaded left, but we're going to shade right. Because it's just easier to see the answer that way. Ah, the sound of 20 people shading at the same time. Mesmerizing. Okay, what was the next one? The next one, maybe I should just write them here so we can see them. X was less than or equal to 40. Y was less than or equal to, what was Y? 60. And X plus Y is greater than or equal to 70. So let's do the Y equation now. 60, so that's 50, 60 right here. And again, less than means shade down, but we want the opposite, so we shade up. Okay, we've taken care of this guy, we've taken care of this guy. This is an easy one, that's why I don't think I'd bother with technology. Just move the x to the other side, it becomes -1 for a slope, and it has a y-intercept of 70. So there's the y-intercept of 70, and 1 for a slope is a perfectly diagonal line. And this time, I better run a test for this one. I'll test 0, 0. And what I'll see is 0 plus 0 is greater than 70 is false. So I'm shading the opposite. So I'm shading where it's false, right? So in other words, 0 is not part of the solution. So I'm going to shade 0. So that means the answer, we just did one like this kind of as our warm-up today. The answer is this little triangle zone. So what are my potential answers for optimization? So this one is 1060. It does, doesn't it? This one's 4060. And this one is 4030. Okay. This one you can pretty much just do by logic and reason, I think. Right? Think about it. Wouldn't 4060 have to automatically beat 4030? And wouldn't 4060 automatically have to beat 1060? So I think we've got it. So therefore, our profit equation, which was, oh, wait a minute, hold the phone. Is this a profit equation? Read the question more carefully. The company wants to know what combination will result in the minimum cost. Oh, it costs $8 to make a race car and $12 to make a sport utility. So my objective equation is the cost. See, I'm not using P for profit. I'm trying to keep the cost down. Cost is $8 times X plus $12 times Y. I don't want the biggest answer possible. I want the smallest. So let me go back down here to my points that I wrote down. And my cost equation again is 8x plus 12y. And we want to, what's the opposite of maximize? We want to minimize this. So which of those dots will be smaller? Well, obviously it can't be this one. It's going to be either the 1060 or the 4030. So let's try it. Let's try 1060. Oops. Let's try writing that right. There we go. Let's try 1060. Cost is 8 times 10 plus 12 times 60. You can use your calculator if you want, but I think I can do this in my head. That's 80 plus 720. And that's $800 a day of cost. Does the other one beat that? I think it does, doesn't it? If we try the 4030, you get cost is 8 40s plus 12 30s, and that's 320, double check my mental math, yeah, and 360, and that is 680. So that's the one. Therefore, so that's my winner. Therefore, cost is minimized. 680. That's our winner. Do you get why I didn't have to try the other point? I know it'd be bigger than both of them, just looking at it. Cost is minimized at $680 per day when we make, what is it, 40 sports cars and 30 sport utility vehicles. I'll just say SUVs. Subs. Question?
Can I just write cost estimates at 680 per day?
Well, except that the question actually does say, what combination will result? So what combination means how many of this am I making, how many of that am I making? So you better answer it by saying the 40 and the 30. Okay? That's what they want. So there we go. That is, sorry that lesson kind of took a long time. I kind of knew it would. But that is it for lessons for this chapter. So what we'll do is we'll let you have some work time. Don't leave all the homework until Monday, but get some of it done this weekend, and then we'll let you have Monday to work on it some more. And then that gives us Tuesday, Wednesday to review, and Thursday we test. And then this stupid menu keeps coming up, and I don't know why. Go away. Okay, so let me stop the video I'm making.